OLCs are the procedures or techniques that are used to install, inspect, and test intrusion alarm systems. They include methods for selecting and locating devices, wiring and connecting devices, programming and configuring control panels, verifying and documenting system performance, and maintaining and servicing system components. They also include methods for complying with codes and regulations, following safety precautions, and providing customer service only. Here is a brief summary of some of the methods that are discussed in the standard. Selecting and locating devices. This method involves choosing the appropriate types and quantities of devices for the desired level of protection and the characteristics of the premises. It also involves determining the optimal locations and orientations of the devices to ensure effective coverage and minimize false alarms. Some factors to consider when selecting and locating devices are the type of alarm system, hardwired, wireless, hybrid, or microcomputerized. The type of detection device, magnetic contact, motion sensor, glass break detector, smoke detector, panic button, etc. The type of communication method, telephone line, cellular network, radio frequency, internet protocol, etc. The environmental conditions, temperature, humidity, lighting, noise, etc. And the customer's preferences and budget tone. Wiring and connecting devices. This method involves connecting the devices to the control panel or to each other using wires or radios. It also involves using the appropriate materials and techniques for wiring and connecting devices such as wire gauges, connectors, terminals, splices, soldering, etc. Some factors to consider when wiring and connecting devices are the wire length and resistance, the wire color coding and polarity, the wire routing and securing, the wire testing and troubleshooting, the radio signal strength and interference, the radio signal testing and troubleshooting, ITCON. Programming and configuring control panels. This method involves setting up the control panel to operate according to the desired functions and features of the alarm system. It also involves using the appropriate tools and procedures for programming and configuring control panels, such as keypads, computers, software applications, etc. Some factors to consider when programming and configuring control panels are the security level and password protection, the entry and exit delays, the zone definitions and attributes, the alarm reporting formats and protocols, the user codes and authority levels, the system options and settings, ITCON. Verifying and documenting system performance. This method involves checking the functionality and reliability of the alarm system after installation or modification. It also involves using the appropriate tools and procedures for verifying and documenting system performance, such as multimeters, oscilloscopes, logic probes, continuity testers, tone generators, signal analyzers, test signals or simulators, test reports or certificates, etc. Some factors to consider when verifying and documenting system performance are the voltage, current, resistance, and continuity of wires and devices, the signal strength and format of communication methods, the activation and response of detection devices, the operation and display of control panels, the compliance and conformity with codes and regulations, ITCON. Maintaining and servicing system components. This method involves keeping the alarm system in good working condition by performing regular inspections and tests and repairing or replacing faulty or damaged components as needed. It also involves using the appropriate tools and procedures for maintaining and servicing system components, such as multimeters, oscilloscopes, logic probes, continuity testers, tone generators, signal analyzers, soldering irons, screwdrivers, etc. Some factors to consider when maintaining and servicing system components are the frequency and scope of inspections and tests, the identification and correction of problems or errors, the notification and consultation with customers or authorities, the documentation and record-keeping of maintenance activities, etc. Topic 2. The definitions referenced from CAN-OLCs are the terms or expressions that are used to describe or explain intrusion alarm systems. They include definitions for different types of devices, such as magnetic contacts, motion sensors, glass break detectors, smoke detectors, panic buttons, etc. They also include definitions for different types of systems, such as hardwired systems, wireless systems, hybrid systems, microcomputerized systems, etc. They also include definitions for different types of signals, such as alarm signals, trouble signals, supervisory signals, etc. They also include definitions for different types of security levels, such as Level 1, low, Level 2, medium, Level 3, high, Level 4, very high, et cone. Here is a brief summary of some of the definitions that are discussed in the standard. Magnetic contact, a device that consists of two parts, a magnet and a switch. The switch is normally open or closed when the magnet is in contact with it. The switch changes state when the magnet is moved away from it. This device is used to detect the opening or closing of doors, windows, or other object zone. Motion sensor, a device that detects movement in a specific area or zone. It can use different technologies such as passive infrared, here, ultrasonic microwave, or dual technology, a combination of two or more technologies. This device is used to protect large spaces or areas where other detection devices may not be effective on. Glass break detector, a device that senses the sound or vibration of breaking glass. It can use acoustic or shock sensors to detect the frequency or intensity of the glass breakage. This device is used to protect windows or glass doors that may be vulnerable to forced entry on. Smoke detector, a device that detects the presence of smoke particles in the air. It can use different methods such as ionization, photoelectric, or optical beam. This device is used to provide early warning of fire before it becomes too large or dangerous. Panic button, a device that allows users to manually activate an alarm signal in case of an emergency situation. It can be either fixed or portable, wired or wireless, in single action or dual action. This device is used to alert the monitoring center or authorities of a distress situation. 3. Hardwired system, a system that uses wires to connect the control panel to the sensors, devices, and circuits. This system is usually more reliable, secure, and durable than wireless systems, but it is also more difficult and costly to install and maintain. This system is suitable for large or complex buildings that require a high level of protection. Wireless system, a system that uses radio signals to communicate between the control panel and the sensors, devices, and circuits. This system is usually more convenient, flexible, and easy to install and maintain than hardwired systems, but it is also more prone to interference. Hacking and battery issues. This system is suitable for small or simple buildings that require a low level of protection. Hybrid system, a system that combines both hardwired and wireless components to create a customized and versatile system. This system can offer the best of both worlds by using wires for critical or high-risk areas and radio signals for non-critical or low-risk areas. This system can also allow for easy expansion or modification of the system without replacing the entire system. Microcomputerized system, a system that uses microprocessors or microcontrollers to control and monitor the alarm system. This system can offer more features, functions, and intelligence than conventional systems, such as programmability, self-testing, event logging, remote access, and integration with other systems. This system can also use different types of communication methods, such as telephone lines, cellular networks, radio frequency, or Internet Protocol 123. Alarm signal, a signal that indicates an alarm condition, such as an intrusion, a fire, or a panic situation. This signal is transmitted from the control panel to the monitoring center or authorities to alert them of an emergency situation. This signal can use different formats and protocols, such as Contact ID, SIA, or 421. Trouble signal. A signal that indicates a trouble condition, such as a low battery, a power failure, a communication failure, or a sensor malfunction. This signal is transmitted from the control panel to the monitoring center or users to alert them of a problem or error in the alarm system. This signal can use different formats and protocols, such as Contact ID, SIA, or 421. Supervisory signal. A signal that indicates a supervisory condition, such as a tamper switch activation, a valve position change, a water flow detection, or a test mode activation. This signal is transmitted from the control panel to the monitoring center or users to alert them of a status change or event in the alarm system. This signal can use different formats and protocols, such as Contact ID, SIA, or 421. Security level. A level that indicates the degree of protection and performance of the alarm system. The security level is determined by the type and quantity of devices, the type and quality of communication methods, the type and frequency of inspections and tests, and the type and response of monitoring services. The security level can range from level 1, low, to level 4, very high on. Topic 3. The materials referenced from CAN-OLX 14 are the components or equipment that are used to construct or operate intrusion alarm systems. They include materials for wiring and connecting devices, such as wire gauges, connectors, terminals, splices, soldering, etc. They also include materials for communicating and reporting signals, such as telephone lines, cellular networks, radio frequency, internet protocol, central station monitoring, etc. They also include materials for testing and troubleshooting systems, such as multimeters, oscilloscopes, logic probes, continuity testers, tone generators, signal analyzers, etc. Here is a brief summary of some of the materials that are discussed in the standard. Wire gauges. These are the standard sizes of wires that are used to connect alarm devices to the control panel or to each other. The wire gauge determines the current carrying capacity and the resistance of the wire. The higher the gauge number, the smaller the wire diameter, and the lower the current carrying capacity. The lower the gauge number, the larger the wire diameter, and the higher the current carrying capacity. The recommended wire gauge for alarm devices is 22 AWG, which can handle up to 0.92 amps of current tone. For smoke detectors and AC power to the control panel, 18 AWG or larger is required too. Connectors. These are the devices that are used to join two or more wires together. They can be classified into two types, mechanical connectors and solderless connectors. Mechanical connectors are metal devices that clamp or screw onto the wires, such as wire nuts, terminal blocks, or crimp connectors. Solderless connectors are plastic devices that snap or slide onto the wires, such as insulation displacement connectors IDCs, butt splice connectors, or quick splice connectors. Terminals. These are the metal parts of a device that are used to connect wires to it. They can be either screw terminals or plug-in terminals. Screw terminals are metal screws that tighten onto the wires, such as those found on control panels, sirens, or transformers. Plug-in terminals are metal pins or sockets that fit into matching connectors, such as those found on sensors, keypads, or modules. Splices. These are the methods of joining two or more wires together without using connectors. They can be either soldered splices or twisted splices. Soldered splices are made by melting solder onto the wires, which creates a strong and permanent bond. Twisted splices are made by twisting the wires together, which creates a weak and temporary bond. Soldering. This is the process of using a heated iron and metal alloy called solder to join wires or components together. Soldering creates a strong and reliable electrical connection that can withstand vibration, corrosion, and temperature changes. Soldering requires skill and practice to avoid damaging the wires or components or creating cold solder joint zone. Telephone lines. These are the most common and traditional method of alarm reporting. They use the public switch telephone network (PSTN) to transmit alarm signals from the alarm panel to the monitoring center. They can use different formats such as pulse dialing, touch tone dialing, or digital communicator. They can also use different protocols such as Contact ID, CIA, or 421. Cellular networks. These are wireless methods of alarm reporting that use cellular phone technology to transmit alarm signals. They can use different technologies such as GSM, CDMA, or LTE. They can also use different formats such as SMS, voice, or data phone. Radio frequency. These are wireless methods of alarm reporting that use radio waves to transmit alarm signals. They can use different frequencies such as VHF, UHF, or microwave. They can also use different modulation techniques such as amplitude modulation, EMD, or phase modulation, private message rolling. Internet protocol. These are wired or wireless methods of alarm reporting that use Internet Protocol (IPA) to transmit alarm signals. They can use different networks such as Local Area Network (LAN), Wide Area Network (WAN), or Virtual Private Network (VPN). They can also use different protocols such as TCP/IP, UDP/IP, or HTTP. Central Station Monitoring. This is a service that provides 24/7 monitoring of alarm systems by trained operators who can verify and respond to alarm signals. They can use different methods of verification, such as audio verification, video verification, or cross-zoning. They can also use different methods of response, such as calling the premises, calling the authorities, or dispatching a guard to. Multimeters. These are devices that measure voltage, current, resistance, and continuity in electrical circuits and components. They can be either analog or digital and have different ranges and accuracies. They are used to test and troubleshoot wiring and connections of alarm device zone. Oscilloscopes. These are devices that display the waveform of electrical signals in terms of voltage and time. They can be either analog or digital and have different bandwidths and resolutions. They are used to test and troubleshoot communication signals and formats of alarm system zone. Logic probes. These are devices that indicate the logic state, high or low, of a digital signal in a circuit or device. They can have different features, such as LED indicators, sound indicators, or pulse detectors. They are used to test and troubleshoot digital components and circuits of alarm system zone. Continuity testers. These are devices that indicate the presence or absence of continuity in a wire or a device. They can have different features, such as LED indicators, sound indicators, or voltage indicators. They are used to test and troubleshoot wiring and connections of alarm device zone. Tone generators. These are devices that generate an audible tone on a wire or a device. They are used in conjunction with probes to trace and identify wires and connections of alarm device zone. Signal analyzers. These are devices that analyze the characteristics and quality of communication signals and formats of alarm systems. They can measure different parameters such as signal strength, signal-to-noise ratio, bit error rate, modulation type, etc. They are used to test and troubleshoot communication methods and protocols of alarm system zone.